All right, fellow nerds. I'm going to go full nerd today and talk about something that got me genuinely excited. It's Google's new A2A or agent-to-agent protocol that they just announced. You've probably heard a lot about agents recently. Little digital workers that can do a specific job really well, or sets of workers that can do those jobs. But they're not coworkers, oddly enough. Not with each other, at least. So they can't call each other and say, hey, how you doing, man? And what do you do again? And what area do you work in? And do you know anything about, or can you tell me somebody else that knows how to? That's something that they literally cannot do. They always work in their own little silos these days. And it's actually a superpower that humans have. We don't think about it. When I'm at work, I can have a problem, look around, contact a few friends, and say, do you know anybody that does XYZ? They put me in touch with them. I talk to that person. We team up and we solve the problem together. That would be awesome if agents could do that. At least that's what Google thought. So they came up with A2A, agent-to-agent protocol. And today we're going to dive in and uncover why it's the next biggest thing since MCP. And I know that's a ridiculously nerdy thing to say, but MCP was a real unlock. That was the thing that allowed an agent to grab a new tool it had never seen and actually expand itself. That was really critical, and we're just seeing the beginning of that. Right on the end of just seeing the beginning of that, we're now seeing the how do agents essentially use other agents as tools, together cooperatively solving problems. So that's what MCP and A2A really open up for us, is working together, we gain these massive new superpowers. Let's dive in and take a look at what this new A2A protocol really offers. Okay, let's take a quick look at the announcement itself, a little bit about what Google had to say about A2A, and then we will actually go into the repository, take a look at where you might be able to run some of the samples yourself, and I'll run a few at the end of this so that you can see how it's working. The most important aspect of any of this, since it will be difficult to visualize exactly the magic that's happening behind the scenes, is that the systems don't know about each other to begin with. So one system is written to just talk with you, and the other system is written to do one particular job. And the first system has to discover, like actually go out and say, are there any guys that know how to do this? Are there any agents I can put my hands on that do these kinds of things? And just with the information that comes back with this agent card, or kind of this discovery information, this metadata about what the system does, is how it knows the different kind of systems that it can interact with. So it's very, very similar to this MCP idea of a single agent saying, what are the tools that are available to me? Except it's at the agent level, being able to say, what other agents might I enlist to do certain parts of this job? By the way, it is an open source protocol. I think that's great. MCP did the exact same thing. I think for this surface area, we really need as much open source as we can possibly get, because it's going to explode horizontally, and we can't assume that there will be major driving partners in any given area for this kind of stuff. So I think that's really great to see. Some of the design principles here are that it embraces agentic capabilities, which is enabling agents to collaborate in their natural, unstructured modalities. One of the things that you keep hearing about these is it allows different agents from different software structures or development practices to communicate with one another. And that would mean something like you wrote one set of agents with LangChain, and you need to interoperate with another set of agents that were written with something like CrewAI or something like that. And so I think that's a neat way to describe it, but it really is not necessarily material. It would be similar to saying you can write your front-end application to talk to back-end applications that have been written in any language, because it very much is that kind of separation that we're actually talking about. So it's a communication methodology. It's a standardized communication. It's a very simple one, in fact, that you can kind of send a message off in something like maybe JSON RPC structure, a known structure, and it comes back in a known structure as well. So it's that simple to some degree. It does have a little bit of protocoling around how to send messages, how to receive messages, how to stream information, because another thing in here that you'll see, it's built on HTTP, SSE, and JSON RPC. So SSE is just kind of a long-lived HTTP connection, if you will. So I can connect to your web server, and until we agree that we no longer need to be connected, that interface or that connection kind of stays alive, very similar to something like a WebSocket, and that allows for bi-directional information and streaming of information and a whole bunch of very interesting things. JSON RPC is just kind of a messaging standard or something like that, and ways to kind of interact with different services with a standard JSON interface, basically. It also has authentication and authorization built into it, or at least structures to be able to implement those. And that's kind of nice to see that they're thinking up front that this communication platform needs to have a mechanism to be able to OAuth and other things like that within it itself, because at some point your agent will be running in your enterprise, for example, and another agent will be running at a bank. And those need to have privileges and know what scopes that they can kind of communicate within. Kind of an interesting and an important aspect of this, and it really allows for this opening up of what is most exciting about this. And I'll talk about that in just a second. The last one is that it supports long-running tasks. It does everything from quick tasks to deep research that may take hours or even days when humans are in the loop. So you might imagine that in some cases, I have an agent that I hear about, and that agent knows how to fulfill a loan or do a background check is one of the examples they have. And in the card, it might come back and say, this could take up, 2 to 4 days, because what actually happens is I send that information off to ostensibly another agent. And that's nice that they have this concept of sometimes your work will need to kind of asynchronously spread itself out. And once those moving parts are all done, then you can move on with the next step in your process. They also have this concept of notifications. You can assign a notification structure to the agent that you're implementing. You can say, okay, when you're done, here's my interface that I want you to call and give me this information, the response, of course, and this other information, the ID to the request number, those kinds of things back, so that I know what to do with it once you give me this back. Very, very cool. Let me talk to you about the thing that I think is actually very likely the most interesting about this. The thing that's not necessarily being said yet is this creates a new storefront potential. MCP created this as well, that you might be able to go write tools, especially if you had an interface or you had an API or a database that other people might want to use. You might be IMDb, for example, and become an MCP provider of a tool that people can look things up. Maybe that's all you do is a very simple interface to your data. That's one way. But if you use something like A2A that says, oh, I'm actually an agent, and now I have kind of a relationship with you that's a very structured relationship that might actually also be in some kind of privileged relationship, that you have certain scopes. Maybe you have to have authentication with us. You might even have a billing requirement with us. Those kinds of things might come into play. All of a sudden, we're talking about storefronts of people creating agents that are either highly creative, like you might be able to create an agent that creates videos, or create an agent that knows how to translate voice in a perfect way. Those kinds of things might turn into the solutions that my video editing software, for example, might use. When I say, oh, this section, I want to turn it into Spanish, please. And the video editing software says, well, we could write that ourselves, or we can implement this A2A call over to this interface that knows how to do Spanish, but they charge 30 cents per. Do you want to pay it? All of that suddenly becomes possible. And that you can start hearing something like the Apple iPhone kind of app store workspace. That's exciting. That really starts to explode people's opportunities to build in this space. So if you're interested in building anything, understand what this is. Anything in the agent space, if that's the kind of stuff that you're looking to build, understand what A2A can be, because I think this thing represents that storefront. It's also fantastic from your own enterprise. If you have your own company, different parts of your company are building different agents to do different things, you don't have to worry so much as long as they can kind of implement this A2A protocol. Then they can communicate, and each one of them can use the other when needed. That's very exciting. And there's ways with SSE and other protocols to be able to navigate the internal complexities of a network inside of an enterprise, those kinds of things. So it's very interesting. There's some really valuable stuff in what's being presented here in A2A, which is just being called this protocol to make agents talk to each other. It's a lot more exciting than that, I believe. All right, let's dive back in. I want to get to the video here, and then I want to show you sort of this thing in action. Here's a diagram of there's a remote agent and a client agent. Your client agent may have some abilities. It might be able to do its own work on your local data, like it might be local to your information. It might be your photos. It might be enterprise information. And then there's a remote agent that you don't really know anything about, but you have a relationship or a policy, internal policy on how you might communicate with external agents. It just needs to be able to discover them. All of a sudden, the agent that you've written can suddenly get these superpowers that it couldn't get before just by being able to implement these remote agents. Really, what's most important, and we've seen this previously with MCP, is discoverability. This idea that it can go and use the information on that discoverable kind of metadata to know what each utility can do. Like, I can call somebody and they can tell me some things about what they do. And then I go, okay, if I need somebody to do those kinds of things, I know who to call. That same thing is happening inside of these systems, but it's kind of an automated system. And they call it an agent card here in their world. But let's take a look at someone using one. So this is an example in Google Agent Space, which is also a thing that was kind of announced very recently with Google. But in this agent space, they're doing an example of someone trying to put a job posting out and hiring someone. And it goes pretty far into it. It does not have sound, but I'll kind of talk over it where it becomes interesting. Obviously, the first thing you're doing is you're just working in a chat interface, and that interface doesn't know anything about hiring people. And it uses that card that you just saw to go discover a new agent that knows how to find candidates for a job. And that agent came back and asked some questions. So human in the loop kind of scenario. You needed to respond with those answers, and it negotiates back and forth with the user that's calling it. And that these artifacts are actually supposedly coming from the agent itself. And then assuming interviews were completed, they go back and ask for updates. And these are the candidates who passed the interview. They're pending background checks. And it says, I did do a background check for one, but two others I couldn't because they're not based in the US. And they asked, can you run background checks for non-US candidates? And it started another agent interaction, presumably to find a different, either run through that same background check agent or find another agent to do the same kind of work. So that's that concept of, from a client standpoint, I know it's hard to visualize how this A2A stuff is exactly involved, but the client is essentially something like ChatGPT. It's just Gemini, right? They're just typing into a chat system, let's presume. That client is not sophisticated in any of this. It doesn't know anything about any of this, but it actually can implement it and use it, present the information that came back. You saw the cards of the different candidates that came up. That came back from that agent, as well as being able to present like questions. That agent actually asked the question, do you care what time zones they're in? They had to answer that question, send it back to the agent before that agent task would actually kick off and go do the work. So very interesting, complex interplay for a client application that doesn't know anything about those kinds of things. And that's where these cards or this kind of discoverability comes from. Very interesting. Let's move briefly into, I'll show you where you can get more information about this, and then we'll just run this by hand a little bit so that you can see the interplay. All right, all of this can be found at GitHub with the A2A, the Google A2A project. They have some Git pages here that you can kind of cruise through all of their information. And it's actually a very well written system to kind of understand more about it. The technical documentation goes very nicely, I have to say, into some of the handshakes and relationship communications so that you can see both parts. So if you scroll down, you'll see that agent card. When the agent card is returned, what is actually in it? What's the structure? What's the requirements? That kind of stuff. This is very nice to see. Very often it's kind of an extra step going and investigating exactly what's going to be responded to and how you need to implement it. So it's kind of neat to see that they just spread it all out into a document if you need it. Of course, frankly, I'll say they left the technical documentation as a single huge page, which I find kind of excellent because I'm going to be able to point my future agents or my coding agents at this page and say, here's how it works. Go consume that first and then come on and take my work on. Another thing is them showing information about A2A and MCP. So this is what I was talking about. MCP and A2A are actually really two sides to the same coin. They're really complementary. And reading through this, you can see exactly why they're interested in keeping the two of them together. So this is the Google A2A repository. We don't need to go deep into it. It has a lot of the stuff we've already covered. I have checked this out here in Cursor, and I am inside of some of the samples. So I've walked inside of the samples. Inside of samples, there's a JS source folder. That's where we find ourselves down here. So what we're going to have is we have a movie agent. He's over here. A coder agent. That coder is here. And then we're also running, where is our CLI? This CLI here. So that's all we're running. We're running the CLI in this one, in this terminal pane, and then the coder agent in this pane and the movie agent in this pane. I'll tell you, this is a very specifically written set of tests or of demos. So basically this CLI is just a command line interface, so something you would be in a terminal. It's not pretty, like I said, but it does allow it to communicate with an external service. These will be two different servers that could, of course, be literally running anywhere. But what we will run first is let's run the coder agent. This one started on a specific port, localhost port. This one will start on the same port. So this set of tests is really set up so that this CLI will discover whatever agent is behind this port. So it wakes up and just calls this URL basically and gets back the agent card. So we can't run both of them at the same time. It's not that kind of thing. So if I hit this, you'll see it wakes up and it goes and it calls this, and it calls .wellknown agent JSON. And what comes back is this server's agent card. So it's just a set of JSON that's structured inside of this server's card to describe it. So it sends back, I'm a coder agent. I'm an agent that generates code based on natural language. And then you can ask it anything you want. So I can say, give me a function reverse a string. And of course, so this guy goes off, starts doing his work, and they emits the final file reverse string. He is using Gemini, so he has Gemini credentials to be able to go out and call Gemini. He's communicating back on SSE, and then it marks the event as final and it terminates the connection, I believe. But over here, what we end up with, this is the artifact that was received. It's reverse string, index part one. Part one is text. Here's essentially the string code that we would have gotten back. So if we're using the coder agent. As I said, not super exciting. It's difficult to tell this separation, but essentially this client application is nothing but a system that knows how to take in information and present information back out. It's not really a dumb system at all, but it's essentially a dumb system. And it is discovering the other system to realize, oh, I can do code. Otherwise, I don't send anything to LLMs that the user asks me, so I can't do code otherwise. So that's kind of cool. Let's shut this one down, shut this one down. Okay, let's start the movie agent and let's start our communication agent, and our CLI agent is telling us this is the action card I got, or the agent card. He's a movie agent, an agent that can answer questions about movies and actors using TMDB. And I'll say name the main male and female and male leads of In Time. Justin Timberlake and Amanda say I could have chosen anything. Okay, I've tried 3 times. I can't do this. So the leads are Justin Timberlake and Amanda Seyfried. I'll say Amanda Seyfried. I'm sorry, Amanda. You were great in that movie. I'm sorry, I can't pronounce your last name. I'm an idiot. All right, so what we've seen here is, of course, we can ask questions. Let's say, and this is just horrifying. So interesting. Okay, I got this wrong. This is cute. So I asked what was the rating of In Time, the movie. And what we're seeing on the other side is the movie agent is taking on this information, and it gets an unexpected final line from the prompt that says, I don't have access to ratings. I can only search for the movie. Would you like me to do that? Defaulting to completed. So let's say, what is the score for In Time? What is the user rating for the movie In Time? Arr. How long is the movie In Time? Okay, this is useless. I found a movie titled In Time, released in 2011. However, I do not have the movie's duration. What is the overall theme of In Time? All right, and so presumably, don't really know this, what's happening on the right side is the movie agent, I apologize, demos are a mess. The movie agent on the right side is just going to TMDB, getting information back, and sending that information back to the user. All right, so that's us having a conversation with the movie agent doing its thing. Let's get out of here. All right, so that's it. I hope you learned a little bit about this A2A or agent-to-agent protocol that they're presenting. It's just a communication protocol largely. It's got a lot in it, so it offers a lot of extensibility that I think that we really need. But really, most important, the thing that really is worth hearing here is this really is important. This is a truly important kind of concept. Adopting some kind of interface like this so that we have some standardization across how these systems can communicate is an enormous unlock for us. I cannot describe how important this is going to be going forward. By the end of the year, I would imagine these things will be getting used universally by everything, and we won't be talking about it. I think it'll be picked up that fast. So dive in now. All right. I apologize for the wonky demo that this presented. It was a little bit of a mess. I definitely had some challenges, and it was not exactly an attractive demo. I just got super worked up about this A2A thing when I started reading about it. I was supposed to look into all the stuff that Google was doing in the last week, and the reality was this one caught my eye so much that I just dove pretty deep on it, and I thought I would really tell you about it because I think it's maybe one of the most important things that they actually presented. Thanks for coming along on the ride for this one, and I'll see you in the next one.